As we were looking at convergence for a power series in section 8.8, finding the radius and the interval of convergence, and what we got to on the first couple problems is that we had a convergence of just at the center, and then this for the second one we had convergence that was the whole number line. There was an infinite interval of convergence. So this next one we had centered it at 2, c is equal to 2, and then we did the ratio test. And with the ratio test, then as we work down here, we're seeing that the absolute value of x minus 2 over 2 has to be less than 1 for convergence. So we're looking at the convergence because remember we took the limit, and with the ratio test, you have to have the limit is less than 1 for convergence. Greater than 1, it diverges. So we set our expression between -1 and 1 using the absolute value rule, and we get the interval from 0 to 4. Now, so we know that the radius, remember the center is 2, so you're going 2 units out each way from 2 to 0 and then 2 to 4. So with that, then what we want to do is test the endpoints. So we're not sure what happens. We know that the interval of convergence at this point is this whole thing in there, but we're not sure what happens at the endpoints. So that's what we have to test right now. Now, like today, we had the geometric series, and it did not converge when the r is equal to 1. You know it diverges. So geometric series are not going to converge on the endpoints at all. If you recognize it's geometric, then you just say, okay, here's the interval of convergence. It doesn't converge at the endpoints. You can test it if you want to, but you really don't have to, because you know that at the endpoints it will diverge, because then your r value is going to equal 1 at those endpoints. All right, so here's what we have, or greater than 1. So when we have the summation, we're just going to test our original summation, our power series, and we've got x is equal to 0, x is equal to 4. Someone the other day asked if Maclaurin series are power series. Yes, indeed, they are. And so are Taylor series. So just another way that we're using that word. Now, here's what we're going to do. We're going to plug in x is equal to 0 and x is equal to 4. We're going to test to see if either one of them converge. So x is equal to 0, we have n is equal to 0 to infinity, and we have -1 to the n plus 1 power, and then this is going to be a -2 to the nth power over n times 2 to the nth, right? I'm going to do the same thing, working in parallel here. N is equal to 0 to infinity, and then we have the -1 to the n plus 1 power, and then we have 2 to the n over n times 2 to the n. Okay, you can see here the 2 to the n's are going to cancel, right? So this one might be a little bit quicker here to see what's going to happen. So I'm going to write this one first. I'm going to say from n is equal to 0 to infinity of -1 to the n plus 1 over n power here. Now I'm going to stop right there for now. I'm going to come back over here, and you can see that you've got this -1 to the n plus 1 power, and then we're going to make a factor of -1 to the nth power here, and then we've got times 2 to the n. So using our exponent rules, n is equal to 0 to infinity, and then we have this is over n times 2 to the n, and you can see now at this point the 2 to the n's are going to cancel. And what we're left with is the summation from n is equal to 0 to infinity of, it looks like -1 to the, and I'll write it down first, it's going to be 2n plus 1, which is odd, which means that your -1 factor is always going to be equal to just -1, and we can leave it like that. And then it's -1 over n, so it looks like this is just -1 over n, means that it is a divergent p-series, So in this case, it doesn't converge at this endpoint. So on our interval so far, now our solution here is the interval. We already know that we've got 0 is not included. X equal to 0 is not included on our interval, because you're looking at the divergent -1 times the divergent p-series, the harmonic series, if you will. Okay, and then what do we have over here? So we know not at 0, but when we plug in here, it looks like it converges, because we know that the limit is, as n goes to infinity, is 0 of our term a sub n. we know that that's equal to 0. And then we also know that a sub n plus 1 is going to be less than a sub n. So those are your two. So it converges by the alternating series test. AST. So it looks like we have this interval of convergence. So we would say the interval is from 0 to 4, exclusive with the 0 and inclusive with the 4. Okay, so there's the first one, and I'll send out this first video. Remember that we can converge exactly at the center. That means just the center causes it to be equal to 0 or some other constant. And we can converge on an interval, or we can converge on the whole number line. Okay, all right, so I'll leave off with this example 3, and I'll send you the video for example 4.